shape.
They have some strength, but not a lot of strength.
They have some strength, but not a lot of strength,
Okay.
and they're analogous to like a 2x4 stud you'd have in your house.
Okay, yeah, and lighter but durable. So here's the plumbing.
This is the plumbing.
So we're not using iron or aluminum or steel. We're using PVC or what's
it depends on the application. I'm not a plumbing engineer, so I'm not exactly.
But it's
sure,
certainly not metal or wood.
Typically, it's PVC.
Yeah.
Often they can use cast iron and different other materials.
But this building appears that the years they're going to be relying on this. This
right.
is going to have to last.
That's right.
Okay. And you are building around that in your structural engineering.
Yeah, you can see actually that here's some places where we've left them holes to run that plumbing through the slab.
Right, and I can see if I look in there, I can see it continues down all the way through. Okay, and it would be above me. Okay.
Yeah, so these holes are put in before they cast the concrete.
All right.
They'll cast the concrete around it, and now they have a place to actually come back and put their ductwork.
Okay. Is this electrical? Then
This is electrical.
Permanent or temporary?
This is permanent. So you can see it coming out of the concrete slab.
Yeah.
This is actually running inside of the concrete slab.
Okay. What will be here in the finished wall? Will there be a partition?
There will be a partition similar to what we were looking at.
Right across here?
This will run in here. So this has all of their internet power for each individual unit.
Wow. Okay.
So
that's got to last 50 years too.
Yeah, exactly.
Is there a life cycle of a building, these components? What do you typically build in? It's an interesting question. I mean, I realize the plumbing has to last. The electrical obviously is a permanent installation. So how long are these? Is there a spec, you know?
That is a good question. Actually, I'm going to defer to Jim.
Okay.
Hey, Jim. Yeah. What's our typical life cycle that we consider for these types of buildings?
How long if you're doing the plumbing and you're doing the electrical as permanent? What kind of life, is there a generally accepted standard on what your building should be?
I think the owner's expectations are in the 50-year range.
So I was,
yeah, right there.
I'm a natural construction building kind of guy. I just said about 50 years.
You're right on.
I'll tell you something. I understand that there's opportunities to join the company if you get what degree do you need? Mechanical engineering or
no,
what?
Most of the degrees, it's either civil engineering degree with an emphasis in structural engineering, or there's some schools that actually have a program that's specific to structural engineering.
Okay, so you need a bachelor's degree as a minimum.
A bachelor's of science degree.
Incidental on the career side, just as it's relevant. What kind of people do you want to recruit? What kind of people want to be in this business? Or what kind of high school students or middle school students are the ones that are thinking about this business, and which ones are the ones that would be rightfully thinking about it? Is math a mandate?
Math is a mandate. People that are attracted to the sciences, people in general that like solving problems. You always get the people that were tinkers, if you will, like to take things apart.
So if you're mechanically inclined, that would help, but you can't just be a doer, you got to be a thinker. You got to have the academic training, education.
Math is key.
Okay, so calculus, trigonometry, geometry.
Physics, all the above.
Physics, okay. I know how to use understand theorems and theory and be able to do, what's the term, sequence of operations.
Yeah, in our profession, it's a combination of having that technical skills, but it also has the pragmatic side to it, and that's where the problem solving coming in.
Okay. And by the way, for the middle school students, pragmatic means practical, applied, everyday things, right?
That's correct.
When you're in the academic structural engineering world, you talk about things like you correct people and say it's not cement, it's concrete, and it's not just practical, it's pragmatic. Right?
That's right.
Okay. I'm kidding because of course we're talking in terms that really are very specific to this. When you say pragmatic, I want to kid people, including you. So right now, if a kid is 10, 12, 14 years old, male or female, they could be thinking about this as a career if they like math. It'd be perfect.
They'd be perfect for that.
Okay. Great.
Well, I think we should move up to some of the higher stories in the building. We can kind of get a better view of the construction that's currently going on.
Okay.
Now, what we have in this area is actually a construction sequence issue, and we haven't explained this yet, but our floor slabs have what are called post-tensioning tendons inside of the slab. They don't just have the rebar that we were looking at. They actually have what are analogous to steel rubber bands put inside of the slab.
At a horizontal level.
At a horizontal level.
Okay.
And what those do is when they come along and they stretch those rubber bands, and the building will actually shrink.
What's the term? What are these called technically?
They're called post-tensioning tendons.
You mean the old post-tensioning tendons story?
That's right. That's right.
The concrete post-tensioning tendons.
That's right. Basically,
let me just say that one more time. Let's talk about the concrete post-tensioning tension. What are they called?
Basically, the way to think about it is that after the concrete is placed, so post casting the concrete,
Yeah.
we tension
Yeah.
some strands that are in the place.
Are they
in
called
the concrete.
post-tension strands?
They're called post-tension tendons.
Okay, so
Yeah.
post-tension tendons.
You could get away with strands too. Strands
Okay,
works.
but I want to be sure I'm technically accurate. Concrete instead of cement, post-tension tendons.
Tendons.
Okay, so post-tension tendons run horizontally and they're embedded in the cement?
That's absolutely right. We'll actually get to see some examples of those
Okay.
as we move up in the building.
Let me catch something, be sure you know that I'm trying to be observant here. I believe I'm under a forming piece of plywood then. The cement was poured right up against the plywood above
You're
us.
absolutely right. Now, the reason that this portion is the only portion that's formed is they actually have to wait to pour what's called a delay strip. So they pour the entire floor, then they pull those post-tension tendons, and then the concrete...
See, you
has
were
to
even
stay-
stumbling there for a second.
It's a tongue twister.
Yeah, say it fast.
Post-tension tendons.
He's good.
Yeah.
Can you
Oh,
say
yeah.
it? Post-tension tendons.
Post-tension tendons.
You guys live in structural engineering. Okay.
Not-
So this
not
is
yet.
this is a curing period for the whole building
That's
while it's
right.
under construction.
That's right.
And this crane is here ongoing then throughout the project. That crane is going to be on duty until the end.
Correct.
Sometimes if you have a 20-story building, then you would have one of those 20-story cranes.
That's right. This building is actually going to top out at 10 levels, so it's 9 stories. The roof will be at level 10, so they're able to use actually smaller cranes. They don't need a...
That crane can go up 10 stories?
If not that crane, they'll bring in a larger crane
Wow.
that can when the time comes.
Okay. So Ryan, this, as we walk by, here is how far heating, ventilation, and air conditioning can get. At this point, they've come up to this floor, and this then will go the next level.
Exactly. Like Casey pointed out before, they have to form these sleeves or blockouts or shafts inside the concrete to allow the ductwork to extend through. So that's what we're looking at. Right?
This is where my tour ends. You asking me, there's no stairs?
There's no stairs. We have to start taking ladders to the top.
Hey, I need my stunt double for this one. Come on, you guys. I mean, you want me to go up on this rickety ladder barely attached?
So we already made you an honorary
All right.
engineer.
I'm an honorary engineer, so I've got to do it. Okay, here we go. You guys have to be like commandos out here. It gets rougher as you go higher.
Right.
Okay. And then, of course, even more temporary forming I'm seeing, right? Shoring. Okay. Another one. Where's my elevator? Okay. So this is it. Here's a shear wall.
There's shear wall.
You know, I
Rebar
recognize that. Handles lateral movement in the building, also serves as a support structure from
Yes, it does.
in between floors.
You must have your degree in engineering then.
I'm getting it today. This is neat. This is then behind the scenes what that shear wall looks like inside.
You can see with a cage coming up from below, and then it stops right here, and then they drop another cage of reinforcing steel that sets right on top of it. And it collapses together and splices into one strong cage.
So at the ultimate technical level, you're tying a knot with metal.
No, this
Right?
is just for temporary support.
Good, I'm feeling better. I'm worried about that, you know. Have my family inside a building and think they're being tied together with baling wire or
No,
something.
that's just all to hold it together until they get the concrete in place.
Okay.
Take the beat in the street.